thank you all for being here this morning for the final presentations of the ARC programs. We have the middle schoolers here, and we have groups of high school students and high school teachers that you're going to hear from. I have to do the boring part, so I'm going to go over a little bit of safety information with you. In the unlikely event of an emergency requiring evacuation of this facility, those of you sitting in the front auditorium should exit immediately through the doors on the left and right. Those of you in the back should evacuate through the rear doors. Those on the right side should exit through the glass lobby. Those who are on the left side should continue straight and exit through the broad glass enclosed corridor. There you may exit the building to the left or right. Should one or more of these exit ways be blocked by smoke or fire, please leave through the nearest alternate route. All right, we're all good on that, right? Okay, now we'll get to the good part. It is time to begin with the opening remarks. So first I would like to introduce Dr. Jim Vosberg, who is the director of the Oak Ridge Institute for Science and Education, or ORISE. The ORISE program supports the Department of Energy in areas such as workforce development, scientific peer review, independent environmental assessment, worker health programs, and radiation emergency response. Please join me in welcoming Jim Vosberg.
Thank you, Jennifer. Good morning to everyone. Happy Friday. I'm delighted to welcome you to the final presentation and the recognition ceremony for the Oak Ridge Science Academy and the ARC ORNL High School Summer Math, Science, and Technology Institute. I'd like to take the opportunity to recognize the participants, the students, teachers, and the Appalachian Regional Commission, ARC state offices, and Oak Ridge National Laboratory. We appreciate these partnerships and the value they provide to STEM education and to the nation as a whole. Students and teachers, you're really not the first people to sit here. This is the 28th year of this Summer Institute. We're very proud of that, in the 8th year for the Middle School Science Academy, which is fairly new. Our common goals for students in both programs are to motivate you to continue your education in STEM, in the STEM fields, hopefully. That's what we're looking for. Our goal for you teachers is to expand your passion for these programs. And obviously, by you being here and supporting these programs, you're designating that passion for the programs and for all of us. It's our pleasure to recognize the accomplishments tonight and encourage you to continue your collaboration with ARC, ORNL, and ORAU. Students, we're relying on you to stay in the STEM fields and maintain your excitement for these STEM fields. There's a lot of opportunities for you out there going into high school, college, and so on, and hopefully at our national laboratories. At this time, I'd like to introduce Mr. David Keim. He is the Communication Director at Oak Ridge National Laboratory. As the Communication Director, Mr. Keim is responsible for internal and external communications, community relations, and protocol visits at Oak Ridge National Laboratory. David holds a bachelor's degree in journalism from the Honors College at Ohio University. Please help me in welcoming Mr. David Keim to the stage.
Really glad y'all are here. I hope that you had a good week. Marie said that this was the best behaved group of students that they've ever had. So the drugs that we've put in the water in Oak Ridge have worked. That it was a successful experiment for us. Just kidding, just kidding. Parents are looking at me like, can I have some of that for, you know? Oak Ridge National Lab loves to support this program because we need you to, and people like you to come work at the lab and help us solve the problems we're trying to solve. And we're particularly excited about giving teachers an opportunity because the only way that we're going to get great scientists and engineers is if they have great teachers who keep them inspired to pursue those kinds of careers and those kinds of studies in college. I have a 17-year-old daughter who's going to be a senior in high school at West High School in Knoxville. And I have an 11-year-old son who's a rising 6th grader, so he's going to be a middle schooler. And they both are interested in STEM, in engineering. My daughter wants to study engineering. But she's had a couple of teachers that haven't been very good. And that's been tough for me to watch as a parent, because I see her inherent interest and I realize what she's missing by not having an adult who understands science, who can really teach it to her in a way that it connects to her. Now she's smart, she takes after her mother, and she can figure it out. But if you have a teacher who's interested in inspiring you, tell them thank you. And if you are a teacher who's here, know that how much you're appreciated. And when you get frustrated by the bureaucracy or by the kids who don't drink our water, just persevere, because the work you do is incredibly important. Oak Ridge exists because scientists were just trying to figure out how the world worked. The place that you've spent the last few days was a bunch of beautiful forests and streams and farmland with a few farmhouses and cabins scattered around 75 years ago. It's beautiful. Appalachia is a beautiful place to grow up. I grew up in Pittsburgh, and I've been here forever. And on the other side of the world, in Europe, 75 years ago, some bad things were happening. You had a guy who was telling the German people that they got the short end of the deal after World War I, and the people were out to get him, and they needed to be strong. And his version of that was that it came at the expense of everybody else, particularly Jews. A lot of those high-profile Jewish men and women in Germany were scientists. And some of them thought nothing bad would happen, and some of them left. And what was happening in the scientific community at that time in the 30s and early 40s is they were figuring out how elements work. They were discovering new elements, and they were figuring out how they behaved. And when they split the uranium atom, it released a stupendous amount of energy. And the scientists understood that discovery could solve the energy problem for the world, because it released much more energy than you got from coal or other sources of energy. But they also realized that could be a fearsome weapon if somebody could make it into a bomb. So the scientists had to persuade the government to figure out how to harness that energy. And they wanted the right government to do it. So a lot of scientists from Europe came to Britain and to the United States. And long story short, they convinced President Roosevelt, to build plants to get enough of that uranium material to build a bomb. There's a debate that is not our purpose this morning about whether you should use nuclear weapons or not, but the fact is someone was going to get them. Someone is going to figure that out. And scientists had to be responsible for for the use of that kind of power. So the United States built Hanford in Washington State and Los Alamos in New Mexico, and they built Oak Ridge. They took 60,000 acres of this beautiful land, and they built K-25, Y-12, and X-10. And they built 3 different sites because they didn't know exactly how to get that bomb material. See, the science and the application don't always work at the same speed. They weren't sure which process would yield enough material for a bomb. So at Y-12, they used magnets to separate the uranium isotope that you didn't need, U-238, from the uranium isotope that you did need, which was uranium-235. But in a ton of uranium, only 14 pounds of it is uranium-235. So you had to separate that out somehow. So they used magnets at Y-12. They used basically filters at K-25, gaseous diffusion process. And Glenn Seaborg had discovered how to make plutonium, first man-made element, out of uranium. And we experimented with that at the X-10 graphite reactor, which became Oak Ridge National Lab. And when we figured it out, they mass-produced that at the Hanford site. So Y-12 shipped its uranium to Los Alamos, and they made Little Boy, which unfortunately had to be dropped on Hiroshima. And at Hanford, they generated plutonium, which was put into Fat Man, which was dropped on Nagasaki, and that ended the war, and have never been used since. Now, I tell you all that so you understand how Oak Ridge came about. Out of that experimentation at X-10 came nuclear energy, nuclear medicine. Everyone in this room knows somebody who has benefited from nuclear isotopes, radioisotopes used for medical diagnostics or cancer treatment. That was pioneered at Oak Ridge National Laboratory. 20% of our power comes from nuclear energy. Y-12 continued to work on uranium for nuclear weapons to the present day. K-25 did that throughout the Cold War, and then it's gone. They tore it down. Scientists have a great responsibility to understand how the world works, because you don't know what's going to come of your discoveries or how that's going to be applied. Those scientific discoveries and materials give us the phone in your pocket. Remember, in World War II, they were using vacuum tubes for communications. And the Bell Labs figured out transistors, and then they figured out silicon, and they're getting back to germanium a little bit. That kind of materials research, what does this material do? What's its magnetism? How can we use this? It has allowed us to become technologically advanced. The manufacturing that we do, robotics and 3D printing, computing. We have the most powerful computer in the country at Oak Ridge National Laboratory. But it's now only the 4th most powerful in the world. It was the most powerful when it started, but now China has 2 more powerful, and there's 1 in Switzerland. So is the United States going to continue to do the right thing and be a world leader in terms of the proper application of science and democracy and freedom? And are we going to have the brain power to be first at getting those discoveries and applying them in the right way? We're counting on you. We're counting on you to have curiosity and to have the discipline, the scientific discipline, to make the discoveries that are going to change tomorrow. And we're counting on you to have the work ethic and the ethics to apply them for the good of mankind and womankind, humankind. So thank you for being here. You are part of a long tradition of discovery and innovation that continues in Oak Ridge today. I hope that some of you will be working for us soon. Marie just told me about one of our scientists in particular who came through this program, grew up in Union County and now works at Oak Ridge National Lab. And I just sent you a story about her. So thank you. I hope you've had a good week. I hope you have a great summer the rest of the summer. Teachers, I hope that you've been inspired, and I hope your batteries are recharged a little bit. We're working on that too, actual batteries, making them last longer. But I hope this recharges your emotional battery and your enthusiasm for teaching. And parents, thank you for sending your kids and entrusting your kids to this program for a few days. As a father, I know sometimes it's a big deal for me to send my kids off, especially the younger one. But I think it's hopefully exposed you students to some of the biggest scientific facilities in the country, and maybe helped you understand why it's so important. So thank you very much for being here. Thanks for taking part in this, and I hope to see you soon.
Thank you, David. Appreciate it. At this time, it's my pleasure to introduce Earl Grohl, ARC Federal Co-Chair. Earl was unanimously confirmed as Federal Co-Chair of the Appalachian Regional Commission by the U.S. Senate on March 10, 2010. In his Senate confirmation hearing, Mr. Grohl stated that his objective as ARC Federal Co-Chair would be to ensure that each federal dollar expended by the Commission was an investment in the economic future of the Appalachian families that will generate a return for the American taxpayer. Mr. Grohl has 20 years of experience in Pennsylvania state and local government before joining the federal government. Prior to his appointment as the ARC Federal Co-Chair, Mr. Grohl served as Special Assistant and Associate Assistant Secretary for the U.S. Department of Labor, Department of Government Relations, Deputy Director for the Puerto Rico Federal Affairs Administration. He holds a Bachelor of Arts degree from Rider College, now Rider University, in New Jersey, and a Master's in Public Administration from Penn State University. Earl, appreciate your time. Welcome. Thank you.
I have this thing where I really try to shut down this long introduction, but thank you, Jim, so much. Good morning. It's really great to be here this morning with all of you. First, I want to thank Jim and his team, and Maria and Jennifer, and the volunteers, the teachers, just the whole crew, folks, who have worked really hard the last couple of weeks here and have helped put on a great program. But I really want to thank them for this great partnership the ARC's had with Oak Ridge the last number of years, and really have been so important in making it a success. I also want to recognize that with me here this morning, we have several folks who work with ARC. We have Sandy Donahue, who is the governor's representative from Kentucky. She actually has a vote at the ARC, so she's a big deal in my world. Sandy, it's so great that you were able to make it down, as well as Brooksy Carlton, who is the program director for Tennessee, Kelly Chastain, who is the program director for Alabama, and Andrea Rose, the program director for Mississippi. Andrea is hiding here somewhere. She's right here in front of me. I also need to thank, of course, Amala Halavovic, who is the ARC staff person who is responsible for managing this part of our portfolio and our program. She does such a great job. She has taken over this load from Jeff Schwartz, who for years and years kind kind of hid this from us, but Jeff is still with us. He's just doing some other work. But Emily is pretty incredible in the energy and the way she attacks all of her projects. Now, I also want to recognize and thank the parents for coming today. I know this can be a big deal and a big challenge, but the fact that you have trusted us with your children for the last couple of weeks, we really appreciate that. We hope that we've earned that trust. Now, you should know that I am an experienced camp counselor. I'm an experienced camp parent, and I'm also an experienced camper. So that means I know exactly the questions that you're thinking right now. Number one, who is this guy and how long is he going to drone on for? When is lunch? And when I get home tonight, can I go hang out with my friends? First and most important, at the end of the last picture, the final picture, and we're going to be a lot of pictures this morning, the final picture, lunch is right out those doors. So the trick is, whenever they say we're going to take a picture, come down front and get in the picture and smile, do it. Because the faster you do it, the faster we get to lunch. But you'll see how that works out. The second, in terms of whether or not you can ditch your parents tonight when you get home and go see your friends, they're going to be a little curious about where all this energy came from. I mean, these are the folks who've been getting you up to go to school in the morning, and I would bet you that can be a challenge sometimes. So all of a sudden they're going to see all this energy, all this stuff, all this excitement, and they're going to be kind of curious about it. So my strategy always was, the moment I got in the car on the way home, I started talking about camp. I started talking about every day and everything. And if I ran out of stuff, I would rewind it, and I would run through it one more time. And you know what? It's really pretty interesting. By the time we got home, they were saying, why don't you go find your friends and tell your friends all about this? And so you have to avoid those yes and no answers. You have to avoid having your face stuck in your phone. But you have to engage in a communication. You have to share and explain to them, or at least show them, where all this energy is coming from. Because they're going to be really curious about that. Now, the first question, who am I and how long am I drone on for? Well, I'm the guy who said it was okay for the federal government to pay for the camp and to pay for everything that went into the camp. And I was able to do that, or I do that, because about 8 years ago, President Obama hired me to represent him at the Appalachian Regional Commission. And hopefully in a few months, President Trump will appoint someone to appoint him at the Appalachian Regional Commission so that they can do the same great work. And my job is really to make sure that whenever the Appalachian Regional Commission spends any money, that it's for a good reason. And that no one is wasting the federal tax dollars that your mom and dad and grandmom and granddad pay every year. So to do that job, in order for me to do my job, I ask a lot of questions. And I need to ask you guys a couple questions too. And the quicker we get through these questions, the less I'll drone on for. So the first question is, can I see a show of hands of the students here today who had a good time? Oh, that's really good. I'm so happy. Can I see a show of hands of the campers who here today who saw this as forced labor? Okay, that's really good. That is a relief. That's great. Now, who here would like to learn some more about the subject that you focused in on? Okay. Who here would like to learn a lot more about the subject that you focused in on the last couple weeks? Okay. Now, if it meant that you could earn a boatload of money, who thinks they might be interested in learning a ton more about the subject that you just got a taste of. Okay, that's really good too. Now, wanting to learn more is sometimes called developing a passion. Learning a lot more about a subject often ends up in a bachelor's degree. All good things. The hope of being paid a boatload of money is sometimes called a career. So, from my point of view, I'm really glad to see that we got so many hands up, because it suggests that there is this possibility, that there is this nugget of passion, of energy that can grow, that can germinate, that can end up in a college degree, that can bloom into a career. And at the Appalachian Regional Commission, that's what we call an investment. And that's really part of why we have, over the last 28 years, been using your moms and dads and grandparents' tax dollars to have a camp like this. Because part of our careers and part of our jobs is to plant those seeds throughout Appalachia so that all of our kids have an opportunity to develop their passion, to get this little glimpse of what's out there and what's possible, not only for you, but for your friends and your brothers and sisters. Now, bad news. There's a homework assignment. And remember, I'm a federal official appointed by the President of the United States, confirmed by the United States Senate. So you're going to need to do this. So that nugget that was planted this summer, your job this winter is to take care of it, to water it, to make sure it gets sun and nourish it, help it grow into a real passion. And even on those cloudy, snowy, ugly days where you don't want to leave the house and go to school, that's the day it's most important. That's the day to remember the passion and the energy you felt today as you left Oak Ridge, all of the excitement and all of those things that you learned. That's the day to think back and remember this experience, and to use this energy to push forward and to make sure that you grow your passion, that you go forward and you grow. Because if you do, if you're able to do that, well, that's when you get rewarded with a boatload of money, but not only that, but a lifelong of fulfilling and really exciting experiences. So I just want to thank you all for coming, for playing with us, for participating, and I hope you all have a great school year where you can continue to grow this passion and use this energy that you got here today. Thanks so much. It's great to see you all.
Good morning. My name is Kelly Moore, and I am the program manager for the middle school ARC Science Academy. And this week, we don't say this every year, but we have had the best group of kids in our middle school program. And I know at least a handful of times this week I've received a text, a phone call, an email from a parent saying, hey, I haven't heard from my son or daughter, most of the time son. Are they okay? I just want to check in with them and just hear that they're doing okay. And I think that is really a true testament to how great of a time that the students were having. If they're not calling you and they're not, they don't have something that is an emergency to talk to you about, it means that they're having a great time, they're really busy, they're making friends and they're having fun. And so several times this week I had to track down students and be like, you need to call your mom. Your mom's texting you, send her a text, just so that, we could keep you guys at ease. But they have been a fantastic group. We have outstanding teachers and staff, and I'm really excited to see what the students have to share with you today. So students, if you want to go ahead and come on down, you're ready to do your presentations. Who's first? Allison or Jacob?
Good. Hi, my name is Allison Garman. I'm from 6 Mile, South Carolina. I'm going to tell you about the advantages and disadvantages of solar energy. The advantages are that it's a clean source of energy, it's pollutant-free and noise-free. Did you know that more than 10 times the solar energy reaches the Earth a day than what the U.S. uses in a year? The disadvantages of solar energy is that it's quite costly to get solar panels, and it's not always reliable from, say, there's cloud cover or it's a stormy day. Solar energy still needs more research, but it's a really good way to make your own clean energy.
Hi, my name is Kaylee and I'm from Ray, Ohio. A p-n junction is a space between two types of semiconductor materials, the p-type and the n-type. Inside a single crystal, the positive side contains an excess of holes while the negative side contains an excess of electrons. When p and n semiconductors are joined together to make p-n junction semiconductors diode, this creates a space charge region. When p-n junction materials are placed by each other, they react very differently than when the materials are alone. The current will flow rapidly in one direction but not in the other, creating the diode. When diode is getting airflow, it only goes one way, which creates the wind to inhibit the other way.
My name is Morgan Hinkle. I'm from Lee County, Kentucky, and I'm going to tell you about series circuits. In a series circuit, there is one path for electricity to travel. The positive charges are connected to the negative charges. Say you have a series of solar cells. If one cell dies or there's a bad connection, you will lose power. If you want to know how many watts, amps, and volts you have, you use a few rules and formulas. Watts equals volts times amps, volts equals watts divided by amps, and amps equals watts divided by volts. The volts will increase with each cell, and the amps will stay a constant number.
Hello, I am Joseph Nodine, and I'll be telling you about parallel circuits. A parallel circuit is a closed circuit in which the current divides into two or more paths. During a parallel circuit, the amps will add together while the voltage will stay constant. Unlike a series circuit, a parallel circuit is connected by negative to negative and positive to positive. If you were to have a set of solar cells and one goes bad or malfunctions, the others will still operate.
Hello, I'm Simon Melton, and I'll tell you about series and parallel circuits and the data we collected about them. Series and parallel circuits can both be measured and tested in various ways. To test these circuits, we used small solar panels to power them and UV sensors to detect the amount of light. After lamps were placed above the solar panels, we connected the solar panels together to form a series circuit. After measuring the voltage of the amps of the series circuit 3 times, and amount of amps of the series circuit 3 times, we found that the average of volts was 4.34 and the number of amps was 0.18. The parallel circuit had a voltage of 3.7 volts and had 0.55 amps. The number of watts of the series circuit was 0.78 and 2.03 for the parallel circuit.
Hello, my name is Casper Heitman from West Valley, New York. So, the solar farm. It was a fun little trip where we learned a surprising amount, including that it was a 1 megawatt system. For those wondering, that's 1 million watts. However, that amount of electricity doesn't just start out as, helpful electricities. It starts out as DC, or direct current, which is pretty much useless in our homes. However, once it goes through an inverter, it becomes AC, or alternating current, which is much more helpful. Then it goes through a transformer, so it doesn't just fry your house.
I'm Leslie Atkinson from Coalfield, Tennessee. This week we were challenged to use solar energy to make something called a worm gearbox. First we put an axle into one of 2 framework pieces after we had placed one of 3 gears on it. Next, we put 2 more gears in the same framework piece to control the ratio of the machine. Then we had to screw on the other piece of the frame. Finally, we attached the motor to one end of the gearbox along with a screw-shaped gear called a worm gear, hence the term worm gearbox. In our case, we had to attach a solar panel to the end of wires for it to run. It's also required to apply a lot of grease to make it run smoothly. However, building it didn't run quite smoothly. Most of us, if not all, ended up messing up or having some other sort of problem. In any case, this type of machine can be used for various forms of work.
I'm Isabel, and I'm from Cana, Virginia. A solar home uses solar energy to heat the water, house, and power electrical appliances inside the home. Your home uses electricity, power that is distributed through wires in your home. Solar homes convert the sun's radiation to electricity. This is done through solar panels, which are long, flat, rectangular-shaped panels that are made up of photovoltaic devices or solar cells. Many solar homes are typical-looking nice houses. Besides the fact they look nice, solar homes reduce your electric bill along with your carbon footprint. By reducing your carbon footprint, you're able to keep the earth in a healthy, clean state.
Hello, everybody. I am John Paul Shields from Clark Summit, PA, and today I'm going to be talking to you about inventing products and our challenge to do so. The first part of inventing a product is coming up with the idea. This also took the longest for our group to do because we had to make an efficient solar-powered machine/invention. The second part is finding out if your idea already exists, because plagiarism is easier than actually coming up with your own idea. I'm kidding, of course. The reason why I say that looking is a step is that if the product you invented already exists, then it isn't an original invention anymore. The third part of inventing a product is planning it out on paper, which I have found is a lot better than just going straight to prototyping. The fourth part of the inventive process is making a prototype to see if the idea that you cobbled together can actually work, which it usually doesn't, the first 100 times. And this led me to the idea of an in-roof heater, water heater. My invention is a water heater that is fitted to the underside of your roof. This heater is powered by sunlight almost entirely. The roof and tank is black due to its heat-retaining properties. An optional induction coil can be fitted to help with the heating of the water. Some advantages of this is that it is cheap and effective, plus it doesn't deface the house at all. In conclusion, I'm very glad that we had this opportunity to talk to you about what we learned about the inventive process in solar energy. On behalf of the Solar Group, I would like to thank Robbie Thomas, Bucky Smith, and our teachers for this amazing experience.
Hello, my name is Zai Kennedy, and this is the Wind Group. This past week, we were asked to make a wind turbine and see who could generate the most power in amps and volts. I think the results really blow you away. First, let me give you a background on wind. Wind is created when hot air rises and then cold air rushes in to take its place. That happens a lot at the beach because the sun warms the ocean slower than it warms the beach, which makes the hot air rise, and when the cold air comes in, it creates wind. Now it's time for my friend Belle Beckner to speak.
Hi, my name is Belle Beckner, and I'm from Clemson, South Carolina, and today I'm going to be talking about the disadvantages of wind energy. So for starters, this wind energy is not consistent. You can't completely rely on it because it's not consistent, and so it's important invest in different types of energy. Another thing is that the construction and repair of a wind turbine is quite expensive. It can cost $500,000 or it can cost $5 million. My last thing is that lightning likes to strike the wind turbines and damage them. It's quite shocking. And now here's my fellow peer, Gavin.
Hello, I am Gavin Autry and I'm from Franklin, North Carolina. I'm going to be telling you about the advantages of wind energy. The first advantage is that wind energy is a clean energy source because it doesn't produce greenhouse gases. Wind energy is also an inexhaustible source of energy. Wind energy is the most cost-effective renewable energy. Finally, wind energy has created more jobs for our country. Now it is time for my friend James to talk about parts of a turbine.
Hello, my name is James Click and I'm from West Virginia. I am going to talk about the parts of a wind turbine. There are 5 important parts of the wind turbine: the rotor, the tower, the generator, the blades, and the gearbox. The rotor is connected to the main shaft, which spins a generator to create electricity. The tower is the housing for the control of the turbine. A wind turbine generator is a device that converts wind into usable electrical energy. The shape and dimensions of the blades of the wind turbine are determined by the aerodynamic performance required to efficiently extract energy from the wind, and by the strength required to resist the forces on the blade. The gearbox is typically used in a wind turbine to increase rotational speed from a low-speed rotor to a high-speed electrical generator. Now it's time for my friend Celia to give you some brief information about Buffalo Mountain.
Hello, my name is Celia and I'm from Cana, Virginia. On Wednesday we went to Buffalo Mountain to see and learn about commercial turbines to help us build better wind turbines and win our classroom competition. We learned from Carl that wind turbines get struck by lightning a lot. A wind turbine from the ground to the top is about 262 feet. The gearbox weighs about 40,000 pounds. Each blade is about 120 feet and foundation is 32 feet deep. The height of the turbine from the ground to the hub is 240 feet, which is taller than an average giant sequoia tree. And now my friend Anthony is going to talk about blade design.
Hi, my name is Anthony Tipton. I'm from Irvine, Kentucky. I will be discussing how design and blade impacts infancy. When the wind reaches the proper speed and the blades will begin to rotate and start producing energy. In order for this to happen, the blades have to be at the right pitch. This will allow the turbine to work best. The length of the blades and the material is made of also play a major part in how well the turbine works. The exact shape of the blade will depend on the conditions where the turbine is placed. Here you can see a group and process of designing and manufacturing our turbines. Now it's time for my friend Madison to speak.
My name is Madison and I'm from Londonderry, Ohio. After we have designed our blades, we cut them out of our material and put them on our wind turbine. Once that is done, we went over to one of the fans and set our wind turbine in front of it. We then turned the fan on and collected data about the volts, amps, and watts. We then calculated the watts by multiplying the volts by the amps. We then calculated the milliwatts by multiplying the watts by 1,000. The reasoning behind calculating the milliwatts was that we thought the milliwatt number made our wind turbine sound more aggressive and powerful. Sometimes we would take the wind turbine aside and make slight adjustments, and other times we would take our wind turbine back to our desk to change or make new blades. Once we started classroom competition, it got really competitive. Kids were trying to find loopholes but failed. Everyone was trying to beat the person in first place. The blades that ended up winning were mine, and their name was Boomerang. They conducted 2,262 milliwatts. Now, Mackenzie will tell you about the test that we conducted at NOAA.
Hi, I'm Mackenzie from Buffalo, New York. After competing in the class with our wind turbines using fans, we decided to take it a step farther. We took them to the NOAA wind tunnel. At the tunnel, the wind can go as high as 14.4 meters per second or 32.2 miles per hour, which is faster than Usain Bolt, the fastest human in the world, while running. Looking at the graph above, you can see that some people's turbines perform better at lower speeds. This is because the air put so much pressure on the blades at high speeds that it caused them to turn and become straight. With this, the blades became stuck and caused the energy output to either stay the same or come crashing down. The winner of the wind tunnel testing was James, whose turbine produced an astounding 7.1 volts. Now Sydney will wrap up the presentation.
Hi, I'm Sydney Vass. I am from Knoxville, Tennessee. I have learned several things from the camp, but what stood out to me the most was going to Buffalo Mountain and seeing how the turbines functioned. Also, I learned how to run our own wind turbines and how to measure the voltage in amps. This was an amazing experience. Special thanks to Mr. Carl Ironman at Buffalo Mountain for showing us the wind turbines and letting us get closer to them and giving us advice on how to use them on our own wind turbines. Additionally, special thanks to Ryan Dosby, Randy White, and David Sin at NOAA for letting us push our wind turbines to the edge and seeing how steady and sturdy we made them. Also, thanks to Lauren Wilmoth for the hands-on learning and Mark Rubin, even though we about killed him in the wind tunnel. My bad. Now, here's Biofuels to tell you about their wonderful experience here at camp.
Hello, I am David Cyphers, and we are the Biofuels Group. All a biofuel really is something that has stored energy inside of it that can be combusted and turned into actual usable energy. And bio just means living, so it can be any plant or oil or anything derived from a living organism. The kind we made was biodiesel, which is a type of fuel made from almost any plant oil that is mixed with an alcohol and a catalyst that after it's refined, it can be used in any regular diesel engine. And it is almost exactly chemically similar to regular diesel fuel.
Hi, my name is Holden Bullock from Sylvan, North Carolina. I'm here to tell you about the process of making the biodiesel. First off, we start with 75 milliliters of our respective oils, being it peanut, soy, canola, and corn, with 25 milliliters of methanol and potassium hydroxide mixture. We mix it first time with 20 milliliters of the potassium hydroxide mixture with a pause to make sure the layers settle into the biodiesel, which is on top, and the waste glycerin, which is on the bottom. And we do a second wash with the rest of it. After the two washes and letting them separate, we have to go to the water wash with 20 milliliters of water to get rid of the excess methanol. And then after the two washes with the water, we have to get it to the heating process to get off any extra water, leaving us with the pure biodiesel, which is ready to combust. Here.
Hello, my name is Dawson Landrum, and I'm from Virginia, and I'm going to tell you how we tested our biodiesel's efficiency. Our biodiesel was tested by burning it. So we took a wick and put it in the biodiesel in a little tray, and we had water in a flask. We put the water over the flame that we lit and let it burn. For a period of over 10 minutes, we had a temperature probe that we let sit in the water. And this, we recorded high temperatures. After this, we then graft it.
Hi, my name is Sadie Shapiro, and I'm from Scranton, Pennsylvania. I compared the data we collected when we burned the fuels. We burned the fuels in a trial run of how well the temperature change under the fuel burning. Now, the first graph that you're looking at is corn. The blue trial, you can obviously see that there's a significant drop from it, from where a dish of ours got to a certain temperature and broke. The next graph you will be seeing will be from the trial from our soy oil. Our soy oil kept in nice and consistent throughout all trials. Canola oil is pretty basically the same in the way that our trials ran. Our last oil that we tried out was peanut. Peanut oil is the most expensive that we had to buy. The trials stopped at red. Our red trial stopped before the 10-minute mark because the oil ran out before the 10 minutes was up.
Hello everyone, my name is Will Shields and I'm a freshman from Franklin, North Carolina, and I'm here to talk to you about our analysis and some of the data that we got from our experiments. So our overall results, our highest efficiency biodiesel was one that was derived from peanut oil, which had a total of 42.55 degrees per gram. Our lowest effectiveness was from the canola-derived biodiesel with 26.1 degrees per gram. And our highest heat output was obviously the corn oil, as it exploded one of our dishes while we were burning it, testing for the heat. And it also got to the temperature at which water boils, which is 100 degrees Celsius. And our most cost-effective was the soybean oil at just a slim $3.50 a gallon. So what went wrong in our experiments? Both the corn and canola oil-derived biodiesels overheated their biodiesel solution, reducing a little bit of efficiency by breaking down some of the bonds within the fuel. So basically, we had to, whenever we did our water washes, we had to evaporate out the water. And we overheated our biodiesel to around 90 degrees Celsius, and that broke down some of the chemical bonds and may have reduced some efficiency. Corn biodiesel caused high heat, exploding the dish twice, which rendered those tests inviable for data. Finally, the canola oil group dropped a flask of water directly into a flame, creating a spike in their data. So, overall, which is the best, you may ask? Well, soybean oil was overall the best because it had a good balance between effectiveness and efficiency, and cost. Peanut oil was very efficient but costly, and you can't find it for any less than $13 a gallon. Corn oil was less expensive, but it also had low efficiency, so it's kind of that middle ground that was, halfway decent, but not too great. So on that note, I will hand the mic over to my good friend, Avery Tate.
Hi, I'm Avery Tate. I'm from Tupelo, Mississippi. Some of the pros of using biodiesel as a fuel is that it releases better emissions, it's biodegradable, hence the bio in biodiesel, and it has a better fuel efficiency compared to regular diesel and conventional oils. Some of the cons are that it has trouble with lower temperatures like -20 and -30 degrees. It gels up and causes the engines to quit working. Then again, regular diesel does this too. We just add chemicals to make it remain a liquid. It's also more expensive to produce commercially, and some engines might require modification to run on biodiesel.
Hello, my name is Rylan Griffin. I'm from Holly Pond, Alabama, and I'm going into the 9th grade, and I'm here to talk about biodiesel today. We basically use it sometimes in Disneyland's trains. They run on biodiesel. Also, the Mark Twain riverboat at Disney World runs on biodiesel. And the U.S. Postal Service uses biofuels in some of their trucks.
Hi, my name is Lily, and I am a rising 8th grader from North Carolina. I'm here to talk about our tour from Wednesday to the National Transportation Research Center and Manufacturing Demonstration Facility. Our tour was led by Dr. Scott Curran, who experiments with engines to figure out how people can use biodiesel in the near future. The NTRC works with efficiency in engines to improve them so they work with biofuels. They also use computers to simulate situations and experiments for further research. Next slide. We also saw the two largest 3D printers in the USA, known as BAM. BAM stands for Big Area Additive Manufacturing. In the MDF, we looked at multiple 3D printed objects made of various materials like ABS plastic, titanium, steel, and a material derived from bamboo. We saw a 3D printed Jeep and house that wirelessly charge each other. They were made in hopes to create a light community to run on solar energy. Now the Biofuels Group would like to thank our instructors, Marcella St. Ange and Kayla Canario, who we also want to thank Dr. Scott Curran for our time at the NTRC. Lastly, on behalf of the entire middle school, ARC Academy would like to say a huge thank you to Earl Gohl, Amelia Halilovic at the ARC, and Pi Mua, Marie Westphal, and Kelly Moore at ORAU. Thank you very much.
Back up. Go ahead.